So let's get started. This presentation is on interactive visualizations with Python. We hope that it's going to be the best workshop of the whole entire conference this year so far. So hopefully we can meet that requirement. So a quick overview of who's in the room. I'm Tim Hogan. I oversee Data Science Bootcamp at General Assembly. It's a 12-week, 53-hour-a-week bootcamp where we cover everything from basic Python to exploratory data analysis to a lot of different machine learning, and then eventually into some of the big data stuff. Previously, I was doing consulting for Deloitte, and we ended up using a lot of different interactive visualizations for problem solving, but also for proposals. People much rather look at interactive visualization than read a 200-page proposal. So they say a picture's worth 1,000 words, then maybe an interactive visualization is 10,000 words. So this is Greg.
Hi, everyone. Greg McLennan. I've worked as a financial analyst for a number of years, mostly working in Python. I'm going to be helping Tim today kind of walk through the Boki library and discuss, kind of the entry-level points, and then also, building some dashboards later on. So look forward to walking through some of that with you guys.
So let's just kind of get a quick idea of who's in the room. How many developers do we have in the room? How many people do research, scientific community? How many people do we have that are managers, business leaders? Consultant? Sure. Yeah, a mix. Anyone here because they thought this thing was about Python to snakes? Okay. At least most of us are in the right room. So hopefully it gives a good idea. From fist to 5, 0 saying, I really have no idea what I'm doing, and 5 is I'm kind of an expert. What sort of background do we have in Python? Just kind of seeing a range here. Okay, so we got all types here. Has anyone made interactive visualizations before with D3, Boki, any of the other ones? Okay, so kind of got a mix of exposure here. So hopefully by the end, you'll all be raising your hands that you're expert at everything. So before we jump in too far, we're a little concerned about the Wi-Fi network here, making sure that everything's working and you guys can actually download everything. So I encourage people to go to this link. I know I kind of mentioned this as people were coming in. ga.co/ODSC-repo. This is the same as it was in the pre-instructions, if you actually read them. Good for you. And what it does is have the installation instructions there. So as I'm kind of doing this first talk, feel free to start downloading things, because sometimes it can take a little while when you have 1,000 people on the network. So I'll give you a minute to look at the link. Okay. So just kind of a high level, what we're trying to achieve today. We're kind of taking a two-pronged approach where we want a top-down approach of just really understanding what are all the different things in the marketplace, what can you do, what's the potential of using interactive visualizations. From the other side, we're going to try to do a lot of hands-on, so you feel like you're comfortable with the framework and kind of getting up and going. Unfortunately, this is it sounds like 4 hours is a long time, but it actually goes by very quickly, so we don't get to as much stuff as we would like. So we're going to kind of pick and choose, but hopefully by the end of this, you feel like we can have the foundations to go further. So by the end of this, you should be able to explain what an interactive visualization is at a high level, kind of some of the capabilities of it, be able to create a simple plot. I'm sure plenty of you guys have done this in other libraries. Be able to create a simple dashboard, and then be able to kind of explain some of the use cases of interactive visualizations. So it's kind of what today will look like. We'll kind of alternate between me and Greg kind of giving you step by step. It'll be about 20 minutes to 40-minute blocks of us talking, and then we'll give you guys about 20 minutes to play with things. So hopefully you feel like you're getting enough hands-on practice and enough variety. Also in the middle, we're going to be taking a coffee break. So if anyone has any good data science jokes, I'd love to hear them. Use them for future lessons. So just kind of a high level, where we use visualizations in the data science process. I'm sure you guys, this is a very long room, and it's a very small projector. So if you feel like you can't see very well, this slide's the worst, but feel free to move forward. So in the data science process, there's kind of 8 main steps. First, we're trying to identify what the problem is. We look at the organizational structure. We try to understand what's going on. We build a problem statement. We create a number of hypotheses around it, and really kind of formulating what's our aim of this project. once we know the aim of the project, we can kind of figure out what sort of data do we need to acquire. Do we do it through an API, database, a random CSV we find on the internet that we don't know what's in it? The next 3 steps, we kind of like parse, mine, and refine the data. This is kind of when we're combining different data sets, refining it, doing any pre-processing, understanding the relationships, looking at the distributions. Then we build our model. We try to optimize any of the different parameters. We kind of evaluate our score. Eventually, we want to present our results. Hopefully, we can make some sort of decision, action items around this. And hopefully, we can deploy and validate what's going on so we can continually iterate on this process. So the big kind of question is like, OK, where in this process do we use visualizations? Well, first, interactive visualizations can be super helpful in identifying the problem. You can look at a very high level, and you can work your way down to do root cause analysis. You can also identify trends and outliers. Any of your exploratory data analysis is a lot easier using interactive visualizations. Instead of having 30 static images, having one interactive plot is much more easier to work with. For feature engineering, a lot of people know that to win Kaggle competitions, you need to really understand how each of the different parameters work together. So for that, it really helps to be able to explore your data in a quicker way. Eventually, sometimes the output all you care about is empowering other people in your organization to be able to do their own analysis. And you can kind of do this through interactive visualizations. So to take a quick look at the app that we're going to build today. This is our beautiful city of Boston here. And what this is it's 311 data. So if someone's not familiar with 311, it's like 911 calls, but for stuff that's not emergency. So it's everything from a sign being broken to an animal being found, and there's just a variety of requests. This is actually data taken just from a couple months ago, so this is actually real data. And each data point is a call or a case of what's going on. So sometimes there's a lot of other information around it, which can be very overwhelming if we try to print this all in static images. So what we're going to do is we're going to create this drop-down. So say that we want to look at animals. This brings up all of our cases over here in a table. So what we can do is we can empower a lot of the different departments in the city of Boston to be able to investigate further and drill down. We could also hover over them and see how long the case has been open. So the blue ones mean that it's on time, and the red means that they're delayed. So this can allow people in the, yep. Yeah. So if you want to zoom in, whoops. Where we set it?
Or even like the web page, just to see the table a little bit better.
Yeah. Great video. You're going to see this a lot more up close when you build it yourself. So you can investigate as much as you want. So from a high level, what are graphical visualizations? Basic definition is just kind of a graphical representation of data where you can use some sort of action or movement. This means that you don't necessarily need to, I don't know how familiar you guys are with a lot of the visualization stuff, but it doesn't mean you need to have it as a plot or chart. Virtual reality and some of these other art forms can be equally as informative. So what better way to show you or talk about interactive visualizations than to show you some? So this is a plot on movie data. This is taken from IMDb. And there's a variety of different features. There's the number of reviews, the dollars at the box office. There's a lot of different metadata that we can investigate. And if we're a production company and we wanted to make the next hit movie, what we could do is use all this data to investigate where's our best chance of making $1 million. Some of the demonstrations I want to show of this are just the different features there are of interactive visualizations. You can build the different sliders to be able to allow you to filter your data, the different drop-downs to investigate different categories, and you can do search fields to be able to drill down. It's very hard to do search fields in static images, trust me. Another interactive visualization you guys have probably seen. How many people have seen Hans Rosling TED Talk? If you haven't, it's worth Google and spending 20 minutes. It's a great example of interactive visualizations. So what this chart shows is each bubble is a country, and each country, or the size of the bubble, represents how big the population is. So if we see this big red bubble here, you can see this is China. And what they were trying to investigate is how does family size and the total children per woman affect your overall life expectancy. And there used to be this idea of like this being the first world and the Western world, and this being the third world, and big families, small lifespan, and high lifespan, small families. And what we do is like can start investigating, and this is something that would be very hard to see in a static plots, because what you'd have is 30, 40 different plots over all the years. But what we can easily do is just play the visualization and watch over time as all these countries are catching up. And you can see that sub-Saharan Africa is still kind of separated here, but watching all the other countries catch up. This is something that would be a great hassle, and you wouldn't necessarily be able to see these trends in a static visualization. So why would we want to use interactive visualization? We can show a lot more dimensions in a lot cleaner way. I mean, you're looking at a big data set. You may have hundreds of different features. It would take you forever to be able to do just static images of every single correlation. But when you be able to quickly filter the data and subset it in whatever way you want by just a click of a mouse, you can get a lot quicker. An example of the one I just showed you, it's a lot easier to see stuff over time. You can see the actual movements. You can see how they progress. You can show movement. Doing any sort of geospatial stuff is incredibly powerful to actually see it in real time. So whether you're doing supply chain analysis or another type of geospatial stuff, seeing things move throughout the system just gives you a lot cleaner picture. It's great for what-if analysis. If you want to examine a lot of different business scenarios, it's great to be able to just quickly change the parameters, change the algorithm, see how does it affect the bigger picture. To quickly make these changes without having to rerun everything is an incredibly powerful skill to have. And obviously, it's a great communication tool. When you want to sell stories, it helps to go step by step. And what you can do is show the data step by step of what's the data look like in the past, what's it look like now, where could it go in the future based on us making certain changes. Also, it looks really good on blogs. So if anyone wants to use it for the blog, I highly suggest it. Me and Greg actually gave this presentation last week in class, and one of my students came back the next day. He spent like an hour on it, and he created this awesome visualization on his blog. So it was actually very impressive that after just this 4-hour workshop, he could create a pretty awesome visualization. So some of you might say that, hey, this looks very familiar. This looks like Tableau. This looks like Oracle OBIE. This looks like ClickView. And the thing is, it has a lot of the same functionality. So why would we use this versus some of the other paid platforms? One, everyone likes free stuff. It's obviously a giant bonus that you can start playing with it. You don't need an expensive license to be able to get started. Two of the really nice things about this package compared to some of the other packages is you can integrate with the whole entire Python ecosystem. Whether you're using NumPy, scikit-learn, you can instantly connect it with all the tools that you already use. Seems like some of you guys are already really good at Python. It allows you to use all those tools. Great integration to the JavaScript ecosystem. As a lot of you guys know, the JavaScript ecosystem is really blowing up, and there's all these different tools and platforms. What Boki does on the back end is just converts it all to HTML, CSS, and JavaScript, which allows you to instantly connect it to a wide array of tools to solve whatever problem you want. Flexibility. Obviously, we always want things our way. It's nice to be able to customize whatever you want, especially if you're already familiar with the technology. There's incredible customization. Everything's open source. You can change anything you want. And if you do, just push it back. People would prefer it. Speed to build dashboards. One of the complaints about a lot of the drag and drop interfaces is if I want to rebuild the same dashboard, now I have to make all the same clicks again. One of the great things about having this in open source and having it in code is that you can quickly copy and paste all your work from other notebooks. So if you see an interactive visualization that you really like, you can just copy the code and then make your changes, put your data set in, and all of a sudden have an awesome visualization. So it's a lot quicker to be able to get things up and running and to see the dashboard. Another huge advantage is just the whole DevOps ecosystem. the fact that, well, one, version control, extremely important whenever you're making changes and breaking things and everything else. But also like deployment to servers. When you have an open source project like this, you can scale it in any way you want. And Boki scales in a great way. Some of the advantages of kind of some of the paid platforms. Obviously here we have a lot of developers, but the fact that you can have non-technical audience build dashboards is a great tool. Obviously you guys are very expensive. It takes a lot to be able to keep you guys on board. To be able to give it to someone who's not as technical is a great advantage. And although some of the graphics look really sexy, whether it's D3 or Boki, sometimes the graphics take a little more to play with. So sometimes a little sexier out of the box of the other platforms. So one of the big reasons to use this is also the fact that you can empower your whole organization. You can allow anyone in your organization to play with your data. Typically, you don't have everyone in your organization have access to your database, so you can selectively show what you want to them. I mean, one of the big reasons you want to do this is a lot of times, like as data scientists, like we don't know the whole domain. We have other people that know the domain a lot better than us, and they might just see a lot of relationships and trends that they have this deeper understanding for. By enabling different domain experts, they really can investigate the problem and then just give you all the stuff to be able to go build your model on top of, a lot of the insights. So hopefully it can reduce your workload. You can easily make this where you have an interactive dashboard and then you just download a CSV or a SQLite database. So what you can do is stop running thousands of SQL queries and get really annoyed by having to go look stuff up for other people. You can let them go do all the work and you can focus on the cool stuff. And the fact that you just quickly throw it on the web allows you to do this anywhere in the world, especially if you work for an international organization. It's a great tool to be able to just quickly send someone a link and have them investigate their own problem. So now Greg is going to kind of give you step-by-step instructions of how to do basic plotting. The way that a lot of this is going to work is we're going to kind of demonstrate the steps that you're going to take or can take. And then we have another notebook for you where you're going to step through it yourself. So hopefully, if you pay enough attention, you'll be able to get all the right answers.
Hey, everyone. So as Tim talked about, we're going to kind of start from the top down. Start really basic. So bear with me in the beginning. It's all going to build to something greater. We've kind of seen that. But I think it really does make sense to really understand kind of what's going on at the lower level to really get the most out of it. So anytime you're starting to look at a library, where to start is kind of the first thing. I'm looking at, a lot of times it may be hard to figure out. We've kind of done that work for you. Boki itself has a few submodules within the library. We'll focus on the Boki plotting submodule. But there are also other options available. The plotting submodule is kind of a great mix between customization and ease of use. Boki.models is very low level. You're basically putting the axes on the graph itself. So you have a high degree of customization, but usually it's kind of overkill for what you need to get done. And Boki.charts is a submodule that allows you really high-level plotting. If you just need to throw up a quick scatter plot, you could do that in 3 or 4 lines of code, and all of a sudden you're done. But it's less easily available if you want to build out a web app or you want to build out something more complicated. So the plotting submodule is all focused around the figure method. If you guys are familiar with matplotlib or Seaborn or some other Python libraries, it's kind of similar sort of setup. So it's a basic empty plot with default values that needs 3 different things to get set up. So the figure method that I just talked about, which basically just puts the plot, blank plot, and gets that figure set up for you. And there's either output notebook, which if you're using a Jupyter notebook, will output the plot within the Jupyter notebook, or you can specify output file, which will generate an HTML file, which you can then show in any browser you want. And then the show method also, like I said, just shows the output. So really simple, basically as simple as you can possibly get. We import the libraries necessary, output notebook, show, and we import figure from Bokeh.plotting. You create the figure, you output the notebook, and you show, and what you get is a blank figure. So there's no data in it, there's nothing attached to it, but really, understanding this at the simplest level is key, because we're just going to keep building and building on top of that. So within the figure method, there's a number of attributes that are modifiable. Some of the ones that are easiest to kind of understand and grasp, and kind of probably the first ones you'll probably want to start playing with, is just the size of the plot itself. So you've got plot height and plot width, which, if you're familiar with Python, you just pass arguments within the figure method. You can specify plot width and plot height. So in this case, we just create a slightly smaller plot, 300 by 300, but you can do whatever suits your needs. So one of the other core concepts of the Bokeh library is the concept of a glyph. A glyph is just a base visual structure that you're going to overlay on these figures. So a glyph can be a circle. Glyph can be a diamond, arc, asterisk. There are a number of different options that you can play with to add along and overlay on the base structure. And each of those glyphs have their own properties that can be modified. So you can easily see how you start laying on more and more things and continually defining the attributes of the glyphs that you're modifying on. So as we talked about, adding a single circle glyph to the plot. So the same structure we saw before, really the only thing we're adding here is we're adding circle to the plot, and we're specifying the x and y coordinates. And we're still calling output to the notebook, and then we're showing P, the figure that now has a circle glyph overlaid on top of it. So what do you get? Really simple. As with both the figure itself and the glyph, there are kind of sensible defaults. As you can see, it figures out the axes itself. There's defaulted colors. A lot of that's kind of figured out for you, but as we'll show, that's all customizable. So you slowly build on this and just keep going. So passing single values is not really that helpful. Obviously, it makes sense to be able to pass lists of values. So you can see that that's also a feature that's easily available. So in this instance, passing a list of x and y coordinate values, and you get a list of points. So as I briefly just mentioned, there's sensible defaults built in. The axes automatically fit the data points. The figure automatically takes default values, and glyphs also have default values of color, shape, size, all that. So modifying those properties. As we had kind of seen, you can pass values through as parameters. There's three that I think you'll probably end up using the most that make sense to kind of get familiar with. So the size, specifically within the circle glyph, it just modifies the diameter of the circle that you're working with. Alpha, which is just the transparency. So it's a value from 0 to 1, 1 being non-transparent, and 0 being you can't actually see the point. And color. So color, it accepts a lot of different values, hex values. You can just specify blue. It'll pick that up. And it also takes color palettes once you start to get to much larger data sets. So kind of building on where we were before, here's our list, adding the circle glyph. And now we've added 3 parameters. We've changed the size now, so we've increased the size to 10. We've changed the transparency to 0.3. And we've changed the color to firebrick red. So all pretty simple. you can kind of see what it's doing. Now you've got slightly larger circles of red color, and they're slightly more transparent. So you're also able to pass a list of values through to modify each point individually. So you can see that we had 6 data points there, 6 for the circle glyph that we passed through. You could pass a list of colors, a list of alpha values, or a list of size values, and the output that you get is, moving from small to large of size, moving from left to right in terms of the colors we chose, and from left to right and from non-transparent to almost, slightly more transparent. So you can see what it did to each individual point when you're passing the list through. Just to give you another look, we just created 3 little lists here and passed them through as parameters instead of single values. So as I alluded to earlier, there's a lot of different shapes that you can overlay on the base figure plot. One of the other ones that is also frequently used is just the line glyph. You can tell that there's probably a lot of different use cases for this. Line charts, any date time or time series analysis, you're probably going to be looking at the line glyph of creating. So similar structure, you just call the line glyph on the plot, and you pass through X and Y coordinate values. And you've got a very basic rudimentary line plot. As with the circle glyph as well, you can create multiple line glyphs. You can either specify call p.line twice to create 2 line glyphs, or there's a function multi-line, and you can pass a list of lists as the X and Y coordinates to create multiple lines. I think it's easier to see just passing 2 through. You can see that we've created 2 lines from lists of X and Y coordinates, and I've created the second line and just created it color red. Finally, I think one of the other most useful glyphs are the patch glyphs. So if you're working with any sort of geographic data and you want to kind of outline a neighborhood or outline a state, this is kind of what you would end up using. The patches are just polygonal shapes, and they're created from a sequence of X and Y coordinates where the last value and the first value connect to each other. So you can see we created 2 patches, same output as the 2 lines before, and you see the last value connects to the first value and fills that in, and the last value connects to the first value and fills that in. So you could see how, given coordinates, you could fill out the shape of a state or a neighborhood or something along those lines pretty easily once you have those values, and color them each accordingly, and so on. So that's the basics of kind of really rudimentary getting started. If you go to the GitHub repo, there are workbooks. And so if you feel like this was very easy and you're very comfortable with Python, work on the practice notebooks and you should be able to fly through. If this is all new to you, look at the practice notebooks, but there's also the solutions notebooks, which you can just practice and play around with, and they're all individually runnable, so you can run the cell. What we didn't mention is kind of this side toolbar here. This is where there are various different, this is box zoom, this is pan, which is just moving around. You've got wheel zoom, which is on if you have a mouse, just a little wheel, or if you have everyone has a trackpad, so it's just with a Mac sliding in and out. Save the figure and reset the figure.
Come back together. In this next lesson, what we're going to cover is I'm going to talk a little bit about the Python interactive visualizations ecosystem, some of the other tools that are out there. We picked what we thought was one of the better ones, but depending on your application, you should always be aware of the other ones. Next, we're going to talk a little bit about the different data structures that the Bokeh model can take. Then we're going to get into just some of the colors of doing different color palettes. And then finally, talking about the different layouts that you can do. So Why use a Python library? Why in the first place? Show of hands, how many people know JavaScript here? Okay, that's one reason that we're doing stuff in Python. It's really nice to be able to integrate with all the other Python tools. And it takes a while to learn. Like JavaScript, yes, you can learn very quickly. But understanding the whole ecosystem of all the other tools in the JavaScript environment, if you try learning Node and NPM and stuff like that, you keep on having to learn a lot to be able to accomplish a very small thing, which can be very frustrating, especially if you're already very familiar with the Python world. Second big reason is switching languages can be a huge hassle. If anyone's had to write in SQL, Pandas, or Python Pandas, JavaScript, TypeScript, HTML, everything else, switching all day can be very annoying. You already have enough context switching between statistics, machine learning, and everything else that you're doing. It's way easier to integrate with other Python libraries. I mentioned that earlier. Instead of having to set up Flask and having different callbacks, all the callbacks are handled automatically, so you don't have to worry about all the different communication protocols between the front end and the back end, which can definitely save you time. I'm going to talk a little bit more about D3 at the end, but D3 can be a bear to learn. I would definitely say if you're going to spend time learning it, give yourself 5 weeks just so you don't get so frustrated with it, because it really could take a boatload of time to really get good at it. So some of the other libraries that you guys are probably familiar with, matplotlib is kind of the de facto, and Seaborn, which is a wrapper around matplotlib, which allows you to have a lot more of the functionalities a lot quicker. Matplotlib does have an interactive mode, but with that, it's not quite web ready. So to be able to solve that problem, someone's come up with this package called MPL-D3, and the hope is to be able to have matplotlib automatically convert to D3. It's going to be a little bit more time. Like if I was going to take my bets of where the next package that's really going to grow, this would be it. But it's a little bit slow for big data sets right now, and I think the functionality will really be built out over the next couple of years. The next one, if you ever Google Python visualizations, you see Plotly is like the first 5 advertisements. It has a lot of the same functionalities as Boki, but one of the cons is a lot of the functionality that you may want is actually paid. So the good things is the ecosystem will grow, and they'll have a lot more functionality over time, but eventually it's going to get closer and closer to a paid application. The last thing I want to mention is Pygale. One of the advantages of Pygale is the fact that you can do an SVG, a scalable vector graphic. So if you need big graphics for projector or small responsive images for a website, sometimes that can be helpful. It's kind of a little bit of pain to get responsiveness in the Boki library. So next, I'm going to kind of give you the next steps that you're going to be able to do during the workshop. We're going to cover the data structures, the colors, and the layout. So we're starting with kind of where we left off. We do the basic figure, we do the output notebook, and we show it. And as you see, we're also declaring the size here. We get the same blank canvas that prepares us for our beautiful visualizations we're going to build on top of it. Next, we can use we could directly pass NumPy arrays, data frames to Boki, or thirdly, we can use a column data source. So the first one is NumPy. It's a computational library. It's written in C, so you can be able to do calculations a lot quicker. And what it does is it has multi-dimensional arrays. And what we can do is we can create one multiple dimensional array with from 0 to 10 with 101 evenly spaced lines. And then we can take an exponential of it. We print out the type to kind of investigate the fact that we're actually passing these types. And what we expect is an exponential chart. And what we get, exponential chart. Great. And what we expected is that we're printing out the actual NumPy arrays. That's exactly what we expected. So next, we can do a pandas data frame. For those that are not familiar, pandas data frame is the same as the R data frame or a similar Excel workbook. It's just a sheet of relational data. So in our example, what we do is the building data, you can see right on the top, is a pandas data frame. What we're doing is selecting 2 different columns. And what we can do is we can pass those columns directly to our glyph on top of it. So What it does is it automatically does all the conversion for you under the hood, so you can instantly pass it. This kind of can help you when you're doing like automatic filtering in a function on the back end of a dropdown. And we get our graph, and you can see that we print out, it's a series, which is a one-dimensional pandas data frame. So under the hood, all this is creating into what's called the column data source, which those are more familiar with JavaScript. It's pretty much just JSON under the hood. So what we're trying to do is kind of convert it, but if we want to do some additional functionalities, we have to kind of declare it ourselves. So this is just kind of equivalent between the pandas data frame and a column data source. And what you can see is that we just restructure it, and what it is just a key list pair or a key value pair. You can see that, you can investigate that a little closer in your notebooks. So some of the advantages that we can do is we can link selections between different plots. So a lot of the dashboards you might see in Tableau or another interactive visualization, one of the advantages is you can like highlight one point and all the other data around it changes. That can be done through the column data source. So it's one data source, and each of them are kind of linked together. The other one, in our application, when you do the hover over and you get all that extra information needs to be declared in a column data source. So to transform a pandas data frame just into a column data source is we use this column data source object, and then we just pass in the pandas data frame. And what we can do is we can investigate it and realize that the keys, similar to the JSON, are actually just all the different column headers. So now, if we want to plot with the column data source, what we can do is take the column data source object, and we can just pass it as a source to our glyph. And then what we can do is just select what we want as our x and y values of the different columns. So that was a question?
Is there an advantage to converting it to a column data source first, or just passing the pandas data frame?
So right here, you can see that what I actually did is I converted it to a column data source here as an object.
Is there an advantage?
Yeah, so if you're doing like the hover over tools, or you're trying to link the plots together, you actually have to do that. It won't work otherwise. Yeah, so pretty much what you're doing is the data structure, by doing it directly into pandas, doesn't allow you to declare those extra features.
It's doing that anyways under the hood, and so it's converting it to that eventually. So just getting familiar with it, a lot of times, it's you're able to get more functionality just because you're once you start building out some of the dashboards, it's easier to just convert stuff up front, and then you can play with it more. So it's just kind of once you understand it a little bit better, it just allows you to have a little bit more flexibility. But that's essentially what it's doing with converting the NumPy arrays and the pandas data frames anyways.
Yeah. You have a question?
Yeah, I will say, shouldn't you just always do that? I know you can pass the data frame, but I had all kinds of trouble getting hover to work and everything else, but I didn't know that little thing.
Yeah.
So why wouldn't you just convert the data frame to that first?
This is just like intermediary steps for people who are really comfortable with NumPy and pandas and just like don't want to make that extra step. I mean, a lot of times it's easier just to jump to the hard thing and figure it out, and then just do that repetitively, because this is how you get all the extra functionality. It's just another step. It's just another object. So yes, that's what I prefer too. So now we're going to quickly jump into colors. So what we can do is we can map different colors to the different categories that we have. So in our example, the app that we're creating today, what we're doing is mapping the red ones as overdue and the blue ones are on time. What we do is we use the categorical color mapper object, and the two arguments that we pass to it are factors, which are all the different categories that we have, and our palette, so whatever different colors that we want to use. Then what we do is we pass that to our glyph property to our glyph, where we have two properties, field, which is the name of the column that we're trying to map, and transform, we pass in our categorical color mapper. So if we take a quick look at that, we declare the different factors. So we have, in this case, we have houses built before 1950 and built after 1950 in our categorical color map. And our palette is red houses and blue houses. So our red will be before, built after 1950, and blue will be the ones that are built before. Then what we can do is down here on the glyph, we have our source here, which we did before, and we have our color, where we map the field to, this is the column in the data source, and then we pass to the key transform our color mapper that you see here. And as you see, if we're trying to evaluate the greenhouse emissions of the different houses, we can see the different colors here. This obviously can get a lot more robust, where we want to have a lot bigger palette for a lot more colors and do it quickly. So what we can do is we can just import colorblind, which is going to be like the blues and the orange that you'll see in a lot of the other visualization platforms. And what you can do is you can specify the number of colors that you want with that platform. If you have more colors in the palette than you have in your categories, it just takes the first couple up to the level. So we import the colorblind and the Veritas ones that we're going to use later. And what we do is, instead of just individually declaring all the different categories we have, we just created that as a list and then just called unique on it to get all the unique different categories. What that will do is map that with the palette of colorblind of the first three, and we'll pass it again to the color here of the color map. And we print out. Now we get the blue and orange that is commonly seen in like Tableau. So if we want to build a lot bigger color palette, so say we're doing some cartography and we wanted to see alcohol consumption across a giant range of things, what we can do is use a spectrum. So we can just import the spectrum of Veritas, and we can pass the palette. And what we want to do is we want to say that the palette goes over the whole list to be able to show our full spectrum. So what we can do is, to our palette, we can pass in the length of the list of all the values. And as we did before, it still passes the color mapper. So we get the range of colors. So next, we're going to talk about layouts. Layouts are super helpful when you're trying to figure out where all the widgets go on your screen. This helps when you have a lot of different plots and you want to be able to arrange them and connect them all. So you can do a quick row layout. As you expect, they're just done across. You can do a column layout with the top and bottom. What you can do is a combination of row and column, where the first two, we have these two on a row, and this one below it. So one thing that you'll notice difference about this than the next one is notice that each one has its own toolbar. So you can examine whatever tools you want, depending on whatever your application is. So here's combination. Here's a grid layout. And one of the benefits of the grid layout is you could have one toolbar. So if you wanted to connect all the plots in some way with one tool, you could do that. So the last thing to mention is just the toolbar location. So far, you've seen it on the top and the right. Now you see it on the left. And that's just by declaring in the layout the toolbar location as left. You can also auto-size it just with the scale width that we're passing to the grid layout object. So now what we're going to do, question?
Is there a chart for like a table so you can include tables as part of your layouts, or is there anything separate for that?
Yep, so we're going to do tables layout later today. It's in the dashboard that you saw, the first one. So what you can do is you can include that right in it.
Okay.
Yep. Let's go back together.
All right, everyone. So you've kind of become familiar with working with Bokeh within the Jupyter Notebook. It's great. I think that's a really good start, getting used to the functionality. A lot of you may be used to Jupyter Notebooks already, but it doesn't take advantage of some of the best features of Bokeh in that you can, it generates HTML and JavaScript for you, writing Python code. So while the Output Notebook feature is really good for kind of showing what you're starting to do within the notebook, if you want to create a dashboard or something else interactive that you either want to host somewhere else or do something else with. It's a little bit different of a process. So we're going to walk through kind of how to build a very basic dashboard. And I'm just going to quickly show you also from the command line of how you would serve the dashboard locally. So all the code is here. So Boki serve, the code we were talking about. This is just a Python script that I've written that we'll walk through. And then -- show is just going to open it up in a browser. So really quickly, if you run this, the dashboard that we talked about opens up. It's got the interactivity that we talked about. You've got hoverovers. It's got a map. It's got this table that can be sorted. It's got the departments that can be sorted. So that's generally how you do that. What we'll walk through now is simply walk through the Python files and the code step by step. And then once we get to kind of the lab portion, we'll have you guys serve each of the files individually and walk through to get a feel for doing it that way instead of running it just in the Jupyter Notebook. So as we talked about, this is going to be a little bit more than just running a simple plot in a Jupyter Notebook. We're going to build a pretty rudimentary dashboard, but there's still a lot more that goes into it that we're going to kind of walk through. So as I just showed you, how to serve a Boki app. You write code, whatever text editor you want, really doesn't matter. And then you serve the Python file in the way we just showed you, doing Boki serve -- show just outputs the file to a browser, and you specify the file name that you want. So we're going to jump right into kind of an entry-level point. Similarly, when we were looking at just showing you the figure and showing you a single glyph, I wanted to try and make it as simple as possible. So I'm going to try and do the same thing here of like, what's the simplest thing that I can throw up here that can run, that makes some sense to you guys? So the first thing to notice that's different is this top import up here. So from Boki.io, import curdoc. Curdoc just stands for current document, and it's going to be where all your figures, sliders, any other interactive widgets are going to be held. So similarly, when you're looking at different ways to present layouts, you're going to be adding kind of a final form layout to the curdoc. And that's this last function call down here where you add root the figure. And that's just at its very base setting up the figure and the data that you're putting in there. So you can think of this as kind of like where am I outputting this layout or outputting this information to? And that's where you have to import curdoc. Everything else from there is going to be a lot of stuff that you've seen before, should be familiar with. So from Boki.plotting, we're importing the figure again. That's just the base figure, no data attached to it. We're importing column data source because we're just going to convert Pandas data frame right to the column data source from the get-go. And of course, you need to import Pandas to import the CSV. You can do it a number of different ways. I'm familiar with Pandas, so that's the way that I like to do it best. So we're just creating a data set, a Pandas data frame here, reading the CSV that's located in the datasets folder. And then what we're doing here is we're just pulling out the X and Y coordinates from the data frame. So we're using the column data source object. The only thing that will look different is we're just specifying what the data is. So we're creating a dictionary with two keys, X and Y. And the values are just the lists of X and Y coordinates from the service request data frame. So this is just an easier way. We'll be modifying this as we go along, but just to kind of get you started of like, what are we going to throw up here? We're just going to throw up points that represent X and Y coordinates. There's not going to be any maps. They're just going to be points. So as you see, we create the circle glyph. and we're calling the two keys we just created, x and y. And we're saying the source that we're pulling from the column data source, the source that we're creating the x and y from is the column data source. So SRCDS is just service requests column data source. And so what does that get you? It's just a basic outline of all the x and y coordinates. In this case, we're using the 311 requests. So you can't really tell, but it's kind of an outline of Boston broadly. There's no you've got the data, you've got the plot. This is going to be opened up in a web browser, but there's no interactivity yet. There's, you can still move around, you can zoom in and all that, but it's pretty boring figure as if. We're just going to continue to build on that, and I'll show you kind of how to add a map, how to add some of the sliders, and go from there. So as we saw, a lot of this you've already really seen. This is kind of like where it is in your in Boki apps. It's just called 311 Dashboard 101. So 101 just being the simplest, and it goes up to 105 as we add features. So you'll notice as I go through the code, it slightly we'll add more and more features to it. But if you understand this base bit, everything else from here is going to kind of flow easily. So the next thing we want to do is we want to add a drop-down. The drop-down menu itself is just this select import. And we're also going to import row. You've already seen this in the layouts that we just went over. So what we're going to do is we're going to output the figure first, and immediately to the right of it is going to be the drop-down menu that we're adding. So we've imported select. Now we need to figure out what options we want to have available, what information is going to be in there, what are we going to call it. So within the select object, there are a few parameters we want to modify. Options are going to be, those are going to be the values that you want to pull out from the list, or from the list or the column that you're trying to access. So in the case of the dropdown, we are looking at the case status of the data frame. And the case status from the data frame has two values, closed or open. So those are our only two options. If you had 8 other options, you would list those here. We chose a pretty simple column, closed or open, really easy to see. Value is just kind of the initial value that you want to initialize the dropdown with. So the first value we're going to have is it's going to be set to closed, and just the title of the drop-down menu. So I just named this object menu, and you can see I've created a layout where it's a row. The first value is the figure, the second value is the menu, and we're going to add the whole layout to the current document. And so, like we talked about, here's this creation of the select or menu object. And now we see it pop up to the right. It's the second value in the row layout. The important thing to note is we didn't add any interactivity here. We just created this object. It's not filtering anything. It's not actually doing anything. So you can drop this down and select open or close, but it's not going to change the data points here at all. And that's our next task. Yep.
When you specify value on the prior menu thing, that just shows you the default, or is that showing you something else?
So it just shows you what comes up first. So if you were to click on this little button, open would be the next value. But if you specified value equals open, open would be the first thing that pops up here.
And
so
if you don't specify, it comes up whoever's first in the list.
Yeah. So here's where you start to get the interactivity, and this is where it makes sense to kind of go through the functions that we created here. So you can see instead now, whereas first we specified exactly what we wanted the x and y to be in the column data source, we put pandas series here. We put the x and y coordinate values in. What we're going to do now is instead we're going to create a blank column data source. And we're going to, depending on what the menu dropdown is we're going to fill in the information here. So that's one thing to note that's different as we're moving along and trying to make it interactive is we're going to set this out as blank. Now here, all this function is really doing is filtering the data frame by the menu value that you've selected. So you've got your two options, closed and open. So it's going to take the menu value, create a temporary data frame from service requests, and then it's just going to filter on that menu value. So if you select closed, it's going to show you all the points that have closed. If you show open, it's going to show you all the points that have open and return the data frame. Very simple. And then the next function we're going to walk through is the update plot function that we've created here. So it's just going to update the column data source that we've created here with whatever value we have selected in this function. So you call the select data function first, and then you select how you want to update the column data source. So down here, we're saying service request column data source dot data, and we're specifying from the data frame what are the two series that we want to pass through. So at this point, we're passing through X and Y coordinate values based on the filter we've already created up here of the menu value. So it should be X and Y coordinate values for only items that have the menu value of closed or only the items that have the menu value of open. And then if you're familiar with JavaScript at all, this will probably look familiar. There's an onChange method where you want to change, we're talking about when you change the value, what do you have attributes, you have the old and the new attributes, and then you want to update the plot. So what that does now is it adds the interactivity where you can see, we add the drop-down menu, we changed the case status from closed to open, and it filtered from the case statuses where it was closed to now only the case statuses where it's opened. So very easy, very simple example, just two options, but important to kind of get started on something like that. So as we've kind of seen, it's kind of useless without a map underneath, and they're just data points that don't really mean anything. Fortunately, one of the things that's great about Boki is it's really easy to add a map. You can see there's not a lot of lines of code. So from within a submodule within Boki, there's a tile providers. A tile, just for me, it's just a map. So we're going to import a particular map. You can go to the documentation. There's 5 or 6 different options. I think they come from OpenStreetMaps. Here we're just, this is just a function we're adding to allow for rendering within the GPU when we open it up in the browser. And then we're just adding this tile to the figure. And that's going to add the map. The other thing we're doing in this code example is we're adding a hover tool. So as you saw kind of in some of the earlier examples, when you hover over things, you can either display information back, change colors, etc. And the hover tool is pretty simple as well. Within hover tool, there are tool tips. And within there, you pass a list of tuples where the first value is just the title you want to show up. So what do you want to call whatever data source you want to pull in? And at source is referencing the column data source key. So you want to be careful with capitalization here. So you see we added a new blank column data source key and value pair. All it's referencing here when it's saying at source is it's saying find the data from the column data source, and in the data find the source key. And so the at there is important. But just know that's what those two things are. And so as we talked about, kind of here are the two pieces of code that get you the maps. Very simple. You select what map you want from the documentation, and then you add using add tile and pass through the map value. And now we've got this nice overview of where the points correspond to Boston's layout. And then the hover tool, you can see it's added another point down here. And you can't see the interactivity yet. We'll show you in some of the other ones. But when you hover over now, you should see the data from the source column data source. And you just do add tool, the hover function that you just defined. So finally, one of the other minor things to edit you can kind of go crazy with, but just really quickly to show, once again, getting back to kind of the earlier stuff we talked about, 3 things that are really easy to change. Alpha, just the transparency, the size of the glyph itself, but there are a lot of other functions as well. So hover color, and hover alpha. So just meaning, what are the alpha and size are kind of the defaults, but what do you want the properties to change when you hover over them? So in this case, when you hover over them, the points become red and they lose their transparency. So another really simple thing to add that if you spend some more time on can really make the plots and the output look really nice. So it's hard to see underneath there, but the points all change to red, and you can see now this is the hover tooltip that we talked about. Source there is just the title, and that's the data from the column data source that we've defined earlier. Same thing, just calling out the code down here. So happy to kind of take any questions from here. I think it makes sense to kind of walk through what we talked about is working in the terminal and serving the Python scripts yourself. If you're feeling like this is very easy, see if you can kind of build it from the 101 dashboard to kind of see if you build out from there. If this is complicated, or you're struggling a little bit, just get practice running the Python scripts individually. See how they change as you go along. See the different differences in the code that we just highlighted, and go from there. Yep.
So your XY coordinates are longitude, latitude, and it knows how to match that up
So-
on the shapefile from the palette?
So I did, good question. So I had to convert them to Web Mercator coordinates, and so it's already converted for you in there. But that is one thing. The maps themselves are not on latitude, longitude. So if you're working with another project and you're trying to figure out why this isn't mapping, you need to convert the coordinates. I'm not as familiar with Web Mercator, but I just know that that's what the underlying tiles are used for. So the conversion's already there with the files you're working with. But if you want to do it on your own and you were given latitude, longitude coordinates, just know quick Google search. There's plenty of functions available to convert those.
There's functions inside Python to do?
Not built in, but there's plenty of people who have written code to convert latitude and longitude to Web Mercator coordinates. So that's another thing. You just have to transform those data points. Well, let's get started. I think hopefully everyone made it back, got some coffee, got some good break time. So we kind of just walked through our first dashboard, walked through kind of the very basics of it. Hopefully it was building on the stuff we talked about earlier, answered any questions you guys kind of had as we kept going. The second dashboard is going to start at a more advanced starting point, just because we've already been through that, and then we'll continue to layer on a few more points from there. And this is the dashboard that Tim showed in the beginning. So we've added the table. We'll be adding a slider, and some of the other features you've already seen already. So as we talked about before, it's back into kind of showing you the code and then showing you what that represents on the dashboard. So kind of review things that we've talked about. Start again with the empty column data source object that we've created. In this case, we're going to have an X and Y keys as well as a department key. So in this example, we're going to create a drop-down depending on the department that is assigned the 311 request. So we're going to leave that list open to be modified further down. As we talked about earlier, here we filter the data frame by the department value. So before we did the menu value with the various options opened or closed. In this case, we have a few different options here. And these are just department head names. So info, you've got park, animals. And as we talked about earlier with the select value, here's the title that we're calling, and info is going to be the value that we initiate it with. So that's going to be the first value up at the top. So we're filtering the data frame depending on that drop-down menu value. And then here, as we talked about, this is where you update the column data source with the values from the filtered data frame. So it's the same update function. Instead of the menu down here, we have the department where we're referencing the data frame Panda series for department. And on change from the department dropdown, we're running the update function. As you saw before, we're putting this in a row layout, keeping it the same as before, and then we're adding that layout to the current document. So what does that represent? And there you go. We've got the departments up here. I'll run it one more time. You can see there are the 7 different departments we had. You're able to drop down by each. That's this on change function here that we're talking about. And then the update function, which is changing what points you're passing through to the column data source. Any questions so far? That was kind of stuff that we talked about in the last bit that we're carrying over again. Okay. So where we talked about before, one thing I didn't mention is that when you're playing around, it might be a nice thing to import a different tile. If you go to the Boki documentation, there are 5 or 6 different tiles you can play around with. We kept the same one just for consistency, so you guys can kind of see the same thing and how it changes. But you can import a few different map tiles. As we talked about before, it's really simple to add it. You just use the add tile function and specify the tile that you want to add. So now you can see we've got our nice little map again that shows the data points. So moving again to the hover tooltip, which we had talked about earlier. So the hover tool, once again, we import it up here, and then we call it. And in this instance, we're going to take an entirely different column for the hover tooltip. So what I added here to the column data source was a days open list. And within the data frame from service requests, there's an integer value for each data point of how many days open has this request been. So we're going to call that, title it days open, and we're going to access the days open key from the column data source. And once again, you access it within the tooltip by specifying @ beforehand, and then specifying the key value. So you want to make sure you get the capitalization correct there. This is the column that you're referencing. So what happens when you do that? Well, you've added that little hover tooltip. As you can kind of see, days open. It's going to hover over. Here's the title that we passed through. You can call it whatever you want, really. And then the value associated with that data point. So in this case, this has been open for 1,910 days. So probably should look into that. It's been a while. And as we talked about earlier, when you add tools to the toolbar, they're just going to pop up along here. you can specify the location of the toolbar. It's easiest just to kind of keep it here for consistency. But you see this little hover over toolbar is now selected there. So adding a little more complexity and kind of continuing going, we're going to add categorical color mapper. We talked about that a few slides back. We're also going to add a status column to the column data source. So once again, creating this blank list. And we're going to add the status to the hover tooltip as well. So we'll just call it status, and we'll reference the status column or the status key from the column data source. So within the status column itself, there's two different values. There's on time or overdue. So from where we talked about earlier, the categorical color mapper takes two different arguments within there. It takes the factors, which we're just going to pass through the status list. So the two different options, on time and overdue, and the palette, which corresponds to the color you want to give to each of those coordinates. So this is just blue, and this is just red. Slightly different variation. And then for here, we're going to change the alpha value to 0.8. Make sure you're specifying the source is equal to the source up here. We want the x and y coordinates to be plotted with the circle glyph. And we want to specify the color here. And so for the color, we just pass through a dictionary where the field key is status. So that's the column that we're going to be referencing. And how we want to transform it by the color mapper that we just created up here. So it's going to look very similar, but as you can see, now we have different colors depending on the status. So you can see this little point here is red, and so the status is overdue. And you see these two different points here, one blue, one red, depending on the on time or overdue status. Yep.
Hover doesn't need that will reference to the source. Does it need that will type the reference where to apply it? Because
So it's gonna look at the column data source and look for a key within the column data source. So this these have to be keys within the column data source here for the hover tooltip. Does that make sense? Or
we have two data sources.
So I'm not sure. You usually you just want to kind of create one. I haven't looked at that, but I'm not sure. You may be able to specify exactly the source. The default is definitely to just take the column data source because you're passing, you're adding the hover tool, so it's going to take this. Yeah.
So that color mapper step is mandatory? Is there another kind of, like in ggplot, you don't need to do that step?
No, so you can, it's much more helpful when you get more colors and more to it than just two. So it's good to kind of understand that. There are other ways to just pass it to the circle glyph, but
Can you just pass the numerical values?
well, you need to when you want to do it by category. So you can lay it out a little bit differently. We may actually show with like an interactive legend after this, where we specify each department by color differently. But if you want to color it by the by values within a column within the column data source, this is just kind of the easiest way to do it. So one of the other things that we kind of showed you at the beginning that we'll kind of just walk through quickly. There are a few important pieces of code here to also highlight. So from the bokeh.models.widgets, we're going to import two new things, data table and table column. So the table that we saw at the end, those are coming from this import. We want to add more information to the data table, that we want to be able to update the table depending on how we're filtering by department or by days open or whatnot. So we have 4 more empty lists that we're going to pass through. These are going to be kind of the tops of the data table. So we've got case title, we've got the source, we've got the ID, and photo. And we're going to add 2 more tooltips here, as you've kind of seen, just kind of adding on. It's just taking a list of tuples. So we're passing through the title, the column data source key down here. And then we're just creating the table. So here, for each table column, you're specifying the title. And then for the field, you're just specifying what values from the column data source you want to take and fill out the data table with. So in the case here, we'll have 4 different columns with these 4 titles. And they'll fill in the data with the field ID from the column data source, field days open from the column data source, title, etc. And then creating the data table, we call the data table function here, specify the source as the column data source, specify what columns, and the columns are just this list that we've created, list of table columns. And then in this case, I've just specified height and width to kind of match the size of the plot that we've already created. So I'm not sure. OK, yeah. And finally, last 2 things we need to do is continue building on this. Is we need to update our update function so that every time we filter the data frame, we're also taking this data from the original data frame and putting that in the column data source. So every time you do select requests, it's giving you all of these as values to these keys in the column data source. And then finally, so we just added a little bit more of a complex layout, but we're going to take the plot first in a row, and then we're going to kind of stack everything up in a column layout. So the first thing that we're going to do is just combine these in a widget box, which just makes the spacing nice. And we're going to put the department drop down first, and then the data table below it. So you think about it, you got the plot, and then basically your widget box with the column layout structure. So what does that look like? Here we've got the departments where you can select data points. Here's kind of the layout that I was talking about. So you've got the row, and thinking of like, this is one like widget box object. And you're going to lay out the widget box in a column format. So the first thing is department, then followed by the data table. Here's where we created the data table that we just kind of showed you and walked through, creating the different columns, and then creating the entire data table structure. And one more time, just to kind of walk through. So say if you were, you wanted to look at all the sign repairs because you know that that's what you needed to do. You were the sign repair guy, and so you had filtered by title, and you wanted to select all the points that were sign repair and see where those are. So you can just select by doing shift and select all those different data points, and then the points that have popped up are all sign repair titles points. You could customize this, add any different number of columns you want, filter by any different data frame, any other data sources you want. And this is still, interactive, and you can zoom in, hover over any of these data points, and it'll pop up some of the same information that we had before. So the last thing we'll talk about, and this is kind of the final dashboard is Departments Dashboard 106. The last thing we'll talk about is kind of the slider. We showed that in the beginning, both with the IMDb database that we looked at and our app that we kind of put together that you guys have the code for. So maybe very repetitive, but you guys are kind of seeing, you can just kind of build and build and build on these and just slowly add things and add more functionality as you need. So what you're going to do is you're going to import the slider object. It's very similar to the menu object. It's just got a number of different attributes to define before you can kind of just toss it onto the plot. Title, as with most of them, what do you want to call the slider? So in this case, we're going to do a slider on the number of days a request is open. What do you want the initial value to be? So the value here we're going to set as 0. Or sorry, the value we're going to initialize it at is 0, and then the start and the end is just going to be what's the range that we're working with. So I just created a max range, so to ensure that there's at least one data point, so we're not pulling up a blank map at any point. So it's just going to make sure that there's at least one data point. And how do we want to step these values up? So we could do it by a single day open, move from 99 to 100. In this case, let's just make it easy. We're going to step by hundreds of days open. So it's going to go from 0. I think it's about 2,000 days open or something is the max, but it's going to step up by 100 each time as you go along. These two, like I said, are just creating this end value for the slider so that we don't end up with no data points in the map at all. So let's see. So to do this, we have to add one more filter to the data frame. So up in this select request function, before we filter by department, what we're going to do is we're just going to filter by days open. So if the days open is greater than the slider value, then we're going to return the data frame. So, and then down here, so the days slider we've created, on change is going to be that same function that we talked about before. So on change from the slider value, we're going to update the function and the data source that we're pulling from. So quickly to show you kind of how that works, you can see we've got the new select requests here with the updated filter. We've added another onChange function. We've physically added the slider to the layout. So this day slider is now fits in between the departments dropdown and the data table we've created. And when you slide it, you can see the number of points slowly go away. And so the points that are left are all data points with values that are over 1,200. So these are all the open requests that are 1,200 days old. The table is only filled with values from that 1,200 days open and up. And we've kind of built another feature on. So this one has a few more features kind of than we had before. Probably, I think it makes sense. You guys are familiar with the layout now. Depending on, you should all be able to serve the apps. If you can't, I'll work with you to try and figure that out. But play around with this one. If you're more and more comfortable, like I said, try and modify the code as you see fit to try and see if you can build some of this out on your own. And obviously, if you have questions, let Tim or I know.
Let's come back together now. So in this last lesson, the two things I'm going to talk about is what can we do with interactive visualizations, and then just kind of a wrap-up of next steps that you guys could take from here. So what are some of the functionality that interactive visualizations give us? We kind of looked through some of them. Drop down, the clicker that drops things down, buttons of any different HTML type, input fields, which we saw earlier on the movies one, level of detail we'll talk about in a minute, and some of the other ones we'll talk about. So drop-downs, what sort of advantages do they give us? One, we can do way faster filtering. If you've ever had to filter 20 different variables in 20 different ways, it becomes pretty time-consuming. To be able to quickly drop down can save us a lot of different time. We can change the underlying data, but we can also change the algorithm that we're running. So you could have a list of different clustering algorithms and quickly see how well they perform. One thing you could do with dropdowns is you could do dependent dropdowns that you could do hierarchy. So you could say one that is a higher level, and then once you click on that, it gives you the options for the lower ones. Buttons. We could do any different type of HTML buttons. We could do radio buttons. We could do checkboxes. And what we could do is it could trigger computation. So whether we want to rerun a whole different statistical analysis, we could trigger that. We could download a CSV. We can empower other people in the organization to download whatever data they want selectively. And what we could do is we could select a variety amount of data and pull back whatever we want with it. Input fields. We can search for certain data. This is extremely helpful if you're working with text or anything else with a lot of different metadata. And what we could do is we could change the input values of our parameter, input values of any of the parameters of our model. So we quickly change it to see how well it performs. And then we could also add a bunch of different additional data points. So say we're doing some sort of business scenario, and we want to add a bunch of data points to see how it affects the overall picture. We could quickly investigate that. So one of the advantages interactive visualizations have is humans instinctively can only look at so much data at a time. It can be very overwhelming. We're in the age of big data where there's huge amount of data sets, but we can't recognize those trends. One thing that we can do is look at it from a system level. We can have all the pictures. So here we could see all the different departments of all the different 311 requests. And we could just say, hey, what's the neighborhood that has the most 311 requests? And what we can do is narrow that down for a more specific solution. So what we can do is give it to the parks. And we can look at the number of days, and we could keep on filtering it down until we look at the detail of the level that we want. Typically, as data scientists, we don't know all the different use cases. We want to be able to just build something and get it out there and have people start using it. And what we allow is other people in the organization to ask their own question and to answer their own question, which will save you a lot of time. So one way you could do this is by hovering over the points, and you can click in it and drill down into it and have a lot more details behind it. So this is a great way to discover features that you didn't think were important, but now that you can look at a different layer, you realize that are. So we're getting to the age where computationally we can achieve so much, but we still need that flexibility and creativity. So one huge advantage that interactive visualizations do is they get us closer to the idea of augmented intelligence. So AI, artificial intelligence, is the whole idea of automating human process. But what we also want to do is be able to use our creativity and our flexible problem solving to be able to work well with computers. They've done a bunch of different studies about taking grandmasters at chess and comparing them against supercomputers. And the competitor against them was a bunch of amateurs in chess and a bunch of amateur laptops. And what they figured out was if you could streamline how humans work with computers, you actually get a lot better result than the grandmaster or the supercomputer. And what we can do is this allows us to interact with each data point as we go. If I'm running a clustering algorithm and there's something I intuitively know about certain data points, the algorithm's not going to necessarily give me a perfect one. This allows me to have flexibility to go examine each of the different points, change the classification of them based on something I know that the computer can't pick up, and reperform the algorithm in a better way. You're going to get a lot better optimization out of this because now all of a sudden we're not only harnessing all the stuff that the computer can do, but all the stuff that we can do. And this is only powerful. The way we can do this is through the interactive visualizations by filtering down, investigating it, making any sort of changes, and then rerunning the different algorithms. This is another great use of an interactive visualization. I don't know if any of you guys have seen this before. This is a company called Stitch Fix, and they pretty much apply data science to the retail industry. And if you're not too familiar with the different algorithms, what they do is allow you to kind of step through how all the different algorithms work. So they have some great explanations. You see some logistics problems here, constrained optimization, step by step. Doing some string matching. some ranking. And what you're doing is, as you're going through this, you're seeing the data move. I mean, data goes back to my original point, data doesn't always have to be just points. It could be pictures. It could be any other visual representation of explanation. And watching how that change can tell a lot bigger picture. So you can explain the past. You can explain what a process is, the steps that you took to be able to solve a given problem. You can explain a strategy. Typically in consulting, we have to figure out, hey, what sort of effects is this strategy going to have? And to be able to play them out in real time, whether it's a simulation or a different type of interactive visualization, is extremely valuable. Also, with data flow, we can analyze things spatially, whether it's trying to figure out NFL formations or supply chain logistics. We could investigate it a little bit further. So the next steps I have suggestion for you is what I call practice, practice, play. The whole idea that sometimes the way I've seen people learn like visualization stuff the best is just playing it and trying stuff and just seeing what sort of happens. You can definitely learn a lot from it. I suggest going to the Boki website, and what you can do is just click on the gallery, see all the different things that you can do. And that's a great thing about code versus some of the other click and drop, point and click solutions, is now you can just bring it down and start playing with the different parameters and seeing how they change it. So change the different colors, put your own data set in, and see how it affects it. So I mean, a common question in this whole ecosystem is, now that we talked about Boki, so in my experience, this is great for getting up and running. This is great for prototyping. You can get a lot of exposure, especially if you're used to Python all day. I have a little bit more background in terms of JavaScript and TypeScript, and also in terms of different web frameworks. So if you're going to plan on doing a lot more of this type of work, I do suggest that it's worth spending the time learning Flask or Django, any other web development environment, and quickly just, what you could do is just pass a JSON array into any of the JavaScript frameworks. And the JavaScript environment is growing way faster in terms of visualization than the Python environment. Obviously, people that like doing graphics, they get first exposed to JavaScript, and they kind of hit the ground running. So just to kind of give you an idea, like that story one was actually D3. But these are a couple other graphs that are in D3. So some of you guys have recognized this as the iris data set. And what it is saying, hey, can we classify the different types of irises based on the different parameters? So the parameter here we have is, I never noticed that, sepal length. My mom's a gardener, I should know this. And what you can do is you can instantly start seeing the trends of the different colors. So what we can do, this is a string graph here. You can start understanding bounds around to get a good classification. So if you're looking at a very large data set and you want to see patterns across a huge spectrum, we did this for, I can't say the name, but there was about 500,000 products, and what they wanted to see is is there any common thread through all of their products? And what they realized is like their quantity size, that's something that they were really good at, is providing small quantity products compared to the rest of the market. This is another interactive visualization. On the left here is all different red wines, and on the right here is white wines, and in the middle here are cheeses. So what you can do is try to figure out what is the perfect cheese. So when we examine, we move in here. Say if I select one of these cheeses.
How did you get these relations, by voting or by?
Yeah, so this is like a network graph. Yeah. So you typically have a very long table which explains each of these different dimensions. Yeah. So you could pass a JSON to it. Let's see. My zooming in capabilities aren't working out very well. But you can see the other cheeses that are very similar to it, but you can also see what sort of wines pair well with it. So this is a great way to show a huge network of data and understand the relationship between them. So whether you want to create the next Facebook or you just want to have a good cheese at your wine party, this is a good solution. So So this is a,
Developed with D3?
so that was also D3. And this last one's going to be D3 too. If you go to jsgraphs.com, it also shows a lot of variety. I know I have that in the notes. A variety of the different charts that you can do with JavaScript stuff. So yes, I encourage the Python community to continually grow in their own visualizations because it is a pain to switch between. But if you do have a few weeks to kill and you want to do something productive, I definitely encourage you to learn Flask and then a JavaScript library because you can get the library up running pretty quick, but understanding the ecosystem could take a little bit longer. So here, there's a lot of different ways to use these network graphs. It's great for looking at stuff at a system level and then keep on investigating deeper and deeper into something. But you can also understand the relationship between words and examining them deeper. So the jsgraphs.com. So me and Greg are going to be around for a little while if you guys want to talk about anything. Some of the things that we can help you with is we have a bunch of free interactive tutorials coming out soon in about a month that are a variety of different topics from all different types of data science, data analytics, a lot of stuff on visualization. I'm hoping to get into D3 stuff soon. So if you want to get on our beta list of interactive tutorials, it's a lot like Codecademy. Come talk to me. I'll add you to the beta list. And when we launch stuff in about a month, you'll get all the updates of good stuff. If you're interested in taking an online or an in-person course, General Assembly is great, and I can help you go through that process. It's a great way to kind of get from zero to hero and learn all the different parts of data science. So whether you've been in the field for a long time and you just want to revive your skills, or you are brand new and you want to jump right in, we can help you, and there's a lot of different options there. One thing that me and Greg can help you with is we spend a lot of time learning as many data science things as we can, so we can help you navigate the system of what's worth your time, what's not, what are some of the pitfalls. So no matter what your direction is to go, we can help you get there in terms of a learning plan. We also like talking about whatever's the art of the possible or the art of the impossible. Always fun to talk about. And if you want to talk about technology strategy or anything, we can hopefully give you a little bit more insight on that. So just kind of a recap of our learning objectives. Hopefully now you can explain what an interactive visualization is, kind of at a higher level. Hopefully you can make a simple graph and a simple dashboard, and hopefully understand some of the use cases of interactive visualizations. So hopefully this was a good foundation to be able to build something bigger. And we thank you guys for coming to our first presentation. So hopefully we hit your requirement of being the best one so far. So.